Hello everyone, we're now on the final part of this paper. So we're getting to the grade 7, 8, 9 questions now. So question 17, it says x is directly proportional to the square of y and y is directly proportional to the cube of z. Z is 2 when x is 32. Find a formula for x in terms of z. Now, it's a bit unfortunate because back in the olden days, they used to like to do a nice one of these questions where it was just one part. But recently, they've been favouring combining two separate kind of proportionality statements together, which makes it a lot trickier for people to get their heads around. So what do we know first? We know that x is directly proportional to the square of y. Okay, so that's just a way of writing that expression there. We know that y is directly proportional to the cube of z. So that's a way of writing that. Okay, now we've got to link these together. Okay, so x is proportional to the square of y. Okay, which in turn is proportional to the cube of z. So what we can say is we can basically replace this one here, the y, because y is proportional to z cubed, yeah, we can replace the y squared with z cubed squared, because it's like y is equal to something times z cubed. So the y gets replaced by z cubed. Now, we can change these into equations by putting in a constant in there. So that means that x is equal to some constant times y squared, which is equal to some other constant times z to the power 6. Now, that I think is the trickiest idea in this whole question. We're linking together the two proportionality statements. So they're kind of like, coming one after the other. Okay, so we've given, and unfortunately we've had to do it that way because sometimes we can kind of like break them down into two separate bits and then combine them. But because they've only given us information about the last part and the first part, we've had to sort of like combine them all in one go. But now we know that we've got this expression that x is equal to some constant times z to the 6, x is equal to some constant times z to the 6, we can sub in the z and x now. Okay, so we're told that x is 32 when z is equal to 2. So we sub in 32 and we sub in 2. So we get 32 equals k1 times 64 because 2 to the 6 is 64. And that gives us that k1 is a half. So there's our formula linking x in terms of z. Not a very nice or a very easy question, that one. Question 18, a vector question. I think this is not too bad of a vector question. It's quite a fair one, I think. OABC is a trapezium. Okay, so O to A is A, yep. A to B is B, yep. O to C is 3B, okay. D is the point on OB there, such that O to D to B to D is 2 to 3. So O to D to D to B is 2 to 3. Now I've written that as, that's another way of saying that that means that O to D is 2/5 and B to D is 3/5. Because if something's in the ratio of 2 to 3, you add together, that means that this is 2/5 and that is 3/5 of the line because you add those two bits together. Okay. We're also told that E is the point on BC, E is the point on BC, such that the ratio of B to E to C is 1 to 4. And again, that means if you add those two together, you get 4 add 1 is 5. So that means 1/5 is how you go from B to E, and 4/5 is how you go from E to C. Okay, so now let's have a look. It says work out the vector to go from D to E. So we want to know, how do we go from D to E? That's what we're after. Well, let's think about our route. To go from D to E, we need to go from D to B up there, and then we go from B to E down there. Okay. Well, what do we know about going from D to B? We know it's 3/5 of O to B. So we've got 3/5 of O to B. And what do we know about B to E? We know that B to E is 1/5 of B to C. So 1/5 of B to C. So let's see if we can break these down now into their relative constituent components. So what is going from O to B? Well, O to B is quite nicely just A add B. So we've got 3/5 of A add B. That's that expression dealt with. How do we go from B to C? Well, to go from B to C, we would need to go along there, that's minus B, down there, that's minus A, and along there, that's plus 3b. So minus b minus a plus 3b is one root along there, along there, along there. And when you collect like terms here, minus 1 add 3 is 2. And then we've got minus 8, and the whole thing is times by a fifth. So when you expand that bracket, you get 2/5 b and minus 1/5 a. We then expand the brackets and collect like terms. And when we do that, we find out we get the expression for d to e is 2/5 a add b. And that's how you would do that vector question. That's quite a nice vector question, in fairness. Now, iteration. This is a question that students do not like at all at GCSE. And yeah, it's quite confusing. Quite often, a lot of students lose marks on this particular question. So it says at the start of year n, so at the start of year n, the number of animals in a population is Pn. At the start of the following year, the number of animals in a population is Pn add 1, where Pn add 1 equals k times Pn. Okay, so all that means is if you've got some animals at the start of one year, you basically times it by k. That tells you how many animals you've got at the start of the next year. You times by k again, that gives you the next year. You times by k again, that gives you the next year. And you keep on timesing by k each time. Okay, so that's what the formula is saying. Times by k, times by k, times by k. So it says at the start of 2017, the number of animals in the population was 4,000. So here we are at the start of 2017 with 4,000 animals. So we're going to times that by k. So that means we have got 4,000 times k. That's how many animals we should start off 2018 with. 4,000 times by k. Okay. And then, so that's the start of 2018. Then we times by 2018 to get to 2019. We're going to times by k again. So that means that 4,000 times by k squared is how many animals we have got at the start of 2019. Because we were at the start of 2017, so we times it by k, that was the start of 2018. We times it by a k again, that's the start of 2019. So there's our expression for the number of animals at the start of 2019. Now we're told that at the start of 2019, there were 3,610 of the animals. So we can form an expression and solve it now. So our 4,000 k squared is in fact equal to 3,610. So we divide both sides by 4,000 and square root it, and that's going to give us our expression for k. And it turns out that k in that case is 0.95, or as a fraction, it is 19/20. A little bit of a confusing question, that one, I agree. Now this question 20, oh my goodness, I remember when doing this paper with my some year 11s, and yes, I don't think almost not many students got this one correct. It's a really tricky question. So in this question, it says Pat throws a fair coin n times. Find an expression in the n in terms of n for the probability that Pat gets at least one head and at least one tail. Now let's think about this. So I've just drawn a little tree diagram. Just imagine that Pat throws the coin 3 times. Okay, so let's just see, just to get, sometimes in maths, it's easier to boil a problem down to a simpler one and just think about what happens in that simpler case. So here I've just boiled it down to, let's imagine that Pat throws the coin 3 times. Okay, so we can have heads, tails, heads, tails, heads, tails, heads, tails, heads. There's all the probabilities. Okay. Now we want to know what's the probability that Pat gets at least one head and at least one tail. So that means the only options that we can't have is we cannot have head, head, head. Okay, because in head, 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 we haven't got, any tails. And we cannot have tail, 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 because if we have tail, 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 we haven't got any heads. So we've got to rule those two options out. We cannot have head, head, head. We cannot have tail, tail, tail. But you know what? We can have everything else, because let's consider one of the branches. Here we've got head, head, tail. Well, does that meet the criteria? At least one head and at least one tail? Yeah, we've got 2 heads and 1 tail. Let's just pick another random branch. Tail, head, head. We've got 1 tail and 2 heads. That's okay as well. So all of these other probabilities in the middle are all fine. Okay, so therefore, if Pat had have thrown the coin 3 times, an expression for the probability that Pat would have got at least 1 head and at least 1 tail would have been 1 minus a half cubed minus a half cubed. In other words, because remember, we times along the branches for probability. Okay, so the probability of head, head, head is a half times a half times a half, which is a half cubed. The probability of tail, tail, tail is a half times a half times a half, which is a half cubed. So 1, which is all of these added up, everything that could possibly happen, take away the two things we can't have, would be the answer. Okay, so now we can generalize this. So let's imagine that Pat had thrown the coin 4 times. Well, all that would mean is that we would have the option that we could not have would be a half to the power 4 and a half to the power 4. Let's imagine Pat had thrown the coin 10 times. It'd still be the same. The only this branch and this branch were the ones that are not allowed, and that would be like a half to the 10 and a half to the 10. So now you can see that we can generalize this. So if Pat was to throw it n times, then the probability for at least one tail and one head, at least one tail and one head, would be 1 minus a half to the n minus a half to the n. And that's how you work that one out. But as I say, very tricky question there. This one's a nice one, I think, but again, it's one that students find quite confusing to understand what exactly it is that's being asked here. Here is a speed time graph showing the speed in meters per second of an object t seconds after it started to move from rest. Okay, there we go. Using 3 trapeziums of equal width, work out an estimate for the area under the graph. Oh, that's good, because actually sometimes they don't do that. Sometimes they just ask you to say find the distance traveled and expect you to form that link. But they have been quite kind in this question by telling us to work out the area under the graph using 3 trapeziums. So that's really nice. So here's our trapeziums then, between t equals 1 and 4. So 1, 2, 3. So we just say for a trapezium, we say we're going to do a half times by the two sides added together times by the distance that they are apart. So a half, the distance they are apart is 1 because they're sort of like on their side. So that's the h, as it were. And then that's like the a and that's the b. So you just do the two sides. That one is 4, that one is 6. So that trapezium is a half times by 4 add 6 times by the distance apart, which is 1. So that's 5. We do the same with the next trapezium. A half times 1 times 6 add 7.2, because that's what that one is. And then finally, the last one, it's going to be a half times 1 times 7.2 add 7.8. You work all of that out, add them up, and that turns out to be a total area under the graph of 19.1. Now, they ask you for the last mark to interpret what this means. Now, what this means is because we've got a speed time graph, and distance is the area underneath a speed time graph, okay? Because distance is speed times time. So the significance of this is the distance traveled by the object. So that's that one. Getting to the end of the paper now, close to the end of the paper, let's look at this next one. Nice little bit of algebra. By the way, if anyone's thinking of taking A-level, these are the kind of questions that are, much more the kind of thing you'll be doing at A-level. So it says, show that 6x cubed over 9x squared minus 144 divided by 2x to the 4th divided by 3 times x minus 4 can be written like that. So step 1, let's see what we can spot. Well, it's the old KFC, keep, switch, flip. So we're going to take that divide, we're going to change it into a times, we're going to keep this one, we're going to switch that sign, we're going to flip this fraction. So we're going to take the reciprocal, okay, of this fraction. So the divide has become a times, and we've taken the reciprocal of that fraction. So that's the first thing to recognize. That's good. This is the difference of two squares, or sometimes referred to as dots by teachers. So that is going to, by us teachers, so that is going to be 9x squared minus 144. So that's going to factorize into 3x minus 12 and 3x add 12. So that's good. Now we're making some progress. So because this is now times, we can start to cancel things out, okay? What can we do? Now notice we can do some further factorization here and take a factor of 3 out of this and write of it as 3 times by x minus 4. And that's useful to us because what that enables us to do is we can say we're going to cancel the x minus 4 and the x minus 4 there. We can cancel that 3 and we can cancel that 3, which is good. We can cancel that 6 with that 2 and write it as 3. So that's looking good. What else have we got? We've just got now 3x add 12, and we've got x to the power. Oh, we've noticed we've got x cubed and x to the 4th. So x cubed over x to the 4th just leaves 1x in the denominator, because practically we have x cubed in the numerator and x to the 4th in the denominator. So cancel, 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 cancel. You just get left with 1x in the denominator. So x cubed over x to the 4th just gives us an x in the denominator. And that's where we've got to so far. So what can we do here now? We can take out a factor of 3 here and cancel it out. So that gives us 1 over x times x add 4, which is perfect because that matches the required form there. So that's question 22, a little bit of algebraic fractions. Now, here's the final question on the paper, and I must admit, I tackled it one particular way myself, but I much prefer the way that this accessible mark scheme has done it. And I think it makes far more sense. So I'm just going to go straight away with the accessible mark scheme because it's really neat what they've done. So what have we got? It says we have here this little two triangles, and it says D is the point on BC such that the angle BAD is x, BAD is x, and the angle DAC is x. That is x as well. Okay. So what can we say? Let's write down an expression for the area of the two triangles. Okay. So the area of triangle ABD. Well, that is going to be a half times AB times BD times by sine of x squared, because area is equal to a half AB sine C. So it's going to be a half times by AB times by AD times by sine of x. So that's an expression for the area of that triangle there. Okay, so half AB times by AD times by sine x. Now let's look at the area of the other triangle. Let's look at the area of the triangle ADC. Okay, so ADC is going to be a half times AD, fair enough. So a half times by AD times by AC times by AC times by sine x as well, because the angle in between is x. So we found two expressions there for the area of each of those respective triangles. Now we can go back and find two other expressions for the area of the triangle now. Now let's imagine, now this is a little bit confusing, this sometimes does confuse people. The perpendicular height, when you're finding the area of a triangle, so here's an exaggerated view there. When you're finding the height of a triangle, it's the perpendicular height. So if that was, say, for example, base, and that was height, the area equals a half the base times the height. The height does not have to be inside the triangle. It can be out of the triangle. So you can see that both of the triangles that were in question here, ABD and ADC, they both have the same perpendicular height here, which we're going to call H. So we can now write two expressions for the areas of these triangles. So let's do the same. Let's do triangle ABD first. So ABD is going to be half base times height. The base is BD and the height is H. So half times BD times H. Let's find an expression for the area. Write down area. The area of the other triangle, ADC. That's going to be a half times base times height, but the base is DC and the height is H. Now we've got four expressions that are equal to each other. Okay, we know that this one is equal to this one. And we know that this one is equal to this one. Okay, so basically, if we kind of like divide them all by each other, so if we say, let's say we take, for example, this equation here, the half a, if we divide that equation by that equation, then that's going to be the same as taking that equation and dividing it by that equation. So in other words, this one divided by this one is the same as that one divided by that one. okay, if that makes sense, because they're just two different ways of writing down the same expressions. So let's write that down. So we've got a half of A times AB times AD times by sine x divided by the half times AD times by AC times by sine x, okay, is going to equal the same as a half times by H times by BD divided by a half times by H times by DC. Okay, so in other words, that divided by that equals that divided by that. So now let's see what can happen here. Well, these halves can all cancel. That cancels, that cancels, that cancels, that cancels. AD cancels here, sine cancels here, H cancels here, and we've just left with AB over AC equals BD over DC. So that's, and let's see if that's what we were trying to prove. We're trying to prove that AB over BD, so AB over BD, oh, hang on a minute. But we have got, what have we got? Right, we're almost there, just one little bit of rearrangement. So we've got AB over AC is equal to BD over DC. So we've got to rearrange it a little bit, okay? So let's times both sides by AC. So that means that AB is equal to BD over DC times by AC. Okay, like that. And then let's divide both sides now by BD. Okay, so that gives us AB over BD equals AC over DC. Oh, hopefully we're there now. So what we've got, AB over BD, AB over BD equals AC over DC, AC over DC. And that is it done. But as I say, yeah, that was an extraordinarily difficult question. But I think that of the two approaches that I've seen, that approach in that simplified mark scheme is the better way to think of that question. Okay, better than this approach I did here, because it involved recognizing that sine of y was the same as 180 take away y, and a bit confusing. So that's definitely an easier approach, but easy as, you know, I think that a lot of people would have found that extremely difficult. I hope you found that helpful, and that completes that paper walkthrough for November 2021 paper 3. I'll see you in the next video.